Welcome to Chemistry with Dr. Z. In this video, I'm going to talk about alcohol reaction. So the functional group of alcohol is the OH or the hydroxyl group. And this OH is responsible for the chemical reactivity or the chemical properties of alcohol. So all the reactions of alcohols will be similar and they are going to be due to the presence of the OH. The first reaction of alcohol is dehydration. And dehydration is basically removal of a water molecule from the structure. When a water molecule is removed from the alcohol, it will give you the corresponding alkene. So basically, if you have ethanol like this one, we're going to remove the OH from here and then we're going to remove one of the hydrogens from the adjacent carbon, and that will lead to formation of a double bond between the two carbons. So that will give us the alkene, which is ethene in this case, plus water molecule. Another example is dehydration of propanol. So if you have propanol, which is 3 carbon atom alcohol, then you're going to remove the OH from this carbon, and then you're going to remove one of the two hydrogens here. So remove this hydrogen, and then a double bond will be formed between these two carbons. So that will give us propene and water. So dehydration means removal of water, and dehydration of alcohols will give you the corresponding alkene. The second reaction is the complete combustion. So complete combustion of alcohols. Alcohols can undergo complete combustion in presence of oxygen in the same way like alkanes, and it's still going to give you the same products, which are carbon dioxide and water. For example, ethanol is used as a fuel because ethanol can undergo complete combustion in presence of oxygen to give carbon dioxide and water. To write the balanced equation, you're going to have ethanol, which is C2H5OH, plus 3 molecules of water. That will give you 2 molecules of carbon dioxide and 3 molecules of water. And finally, oxidation. So alcohols can undergo oxidation. When we talked about the fermentation of glucose to form ethanol, we said that the reaction needs to be in the absence of air, because in presence of air, ethanol can be oxidized to give the carboxylic acid. So this is called oxidation reaction, and alcohols can be oxidized to give carboxylic acids. So if you have something like ethanol, and then you represent the oxidation by putting the oxygen between these two brackets, that will give you the corresponding carboxylic acid. In this case, this is ethanoic acid, and ethanoic acid is the acid that has 2 carbon atoms. In this case, we removed these two hydrogens from the carbon that is attached to the OH group, and we replaced it with one oxygen. So the carboxylic acid is CH3C with a double bond with oxygen and then OH. So this is the ethanoic acid, which is the product of the oxidation of ethanol. So whatever the alcohol you use, you're gonna produce the corresponding carboxylic acid that's gonna have the same number of carbon atoms.